Carrageenan is a material that can be obtained from red seaweeds, which is cultured and harvested in ocean farms in the Philippines, Indonesia, and Malaysia. This material is used as a binder in processed meat, providing a material texture and consistency for keeping its volume intact in storage. Its water retention properties keep the processed meat juicy and not dried or burned when cooked or baked. As an additive in pet food, Carrageenan also acts as a binder, similarly giving volume consistency. While pet food can be used immediately without cooking, Carrageenan provides a texture appropriate for the chewing characteristics of common pets. It is further used as a gelling agent for one of our favorite desserts or merienda, the leche flan, and other desserts gel, like gelatin. Forming gels at room temperature on their own, when dissolved in liquid, Carrageenan is a crucial ingredient for these types of food preparations. The property to gel at room temperature extend the applications in other products, as a stabilizer and emulsifying agent in dairy products, beverages, and juices, and as a thickener for creams and sauces. To provide more information, let us hear from Dr. Romel G. Bacabag.
Three types of Carrageenan are commonly used by industry. Kappa, the rigid version of this material, Iota, the soft version, and lastly, the Lambda, which does not form a gel. In our previous study, mixtures of Kappa and Iota Carrageenan exhibited an effective averaging effect of final properties observed in the final product. Carrageenan mixtures preserve the properties of the Iota and Kappa components, resulting into a viscoelastic hydrogel, a mixture behaving like an elastic solid and the flowing viscous fluid. Carrageenan mixtures have predictable properties that can be associated with the concentration of the Iota and Kappa components, where an increase in Kappa concentration makes the mixture more rigid. We will develop methods for making bioplastics and powders that will dissolve in water at room temperature. Bioplastic preparations will provide an alternative to non-biodegradable materials that easily accumulate as unrecycled garbage. As a highly water-absorbent polysaccharide, Carrageenan cold-soluble powders can be used to form the base for additives in firefighting gels that form a layer for increased heat capacity. As a naturally biocompatible material, its potential use extends to various applications for drug delivery systems in pharmaceutical industries and as a scaffold for engineering artificial tissues and organs. We will study how to further refine the Philippine natural-grade Carrageenan to control its chemical structure and effective physical properties. What we will learn will help us design bioplastics with the desired rigidity and strength, constitute powders that dissolve in tap water without heating, and prepare hydrogels for biomedical use. Our investigations will probe how these materials react to being deformed mechanically and how their microscopic structures form to influence their final properties using technologies we developed at the Medical Biophysics Group and at the University of San Carlos. The project will partner with the MCPI Corporation and international academic collaborators. Daghang salamat.